Circle Foundations with Miss Maynard. So when we first start thinking about circles, we need to remember a few important pieces of terminology, key words. So some of these dimensions involved with our circles, because they're different to other shapes. So just remembering that circumference is like the perimeter, it's the outside edge of our 2D circle. The diameter, that is the measurement across the center of our circle. The radius is the measurement from the origin out to the side, so half of the diameter. Now it's really important that you understand what these keywords mean, because they are the key to understanding our different aspects of our circle. Okay, so also when it comes to circles, we've got this unit called pi that we have to use, our mathematical constant pi. And I'm going to go a bit more depth in a moment into what pi is all about. But here we've got the symbol for pi, and we just need to know that pi is relevant when we're working with circles. And pi, as I said, is that mathematical constant, okay? That 3.1415926 and so on, okay? That value. Now, what is pi? Well, Archimedes, back in the early 1800s, was a gentleman who really liked problem solving, okay, and working with shape and geometry, and eventually circles was one of his things. And he basically found out that if the diameter of a circle was 1, no matter what unit, if the diameter was 1, then the circumference would be 3.1415, so on. Okay, so he established that, okay, if the diameter was 1, the circumference was always that. So there was this relationship between the measurement of the diameter and the circumference. So that mathematical constant he established. So what is the length between the circle's circumference and the diameter? Well, it's pi. If you divide the circumference, whatever value it is, by the diameter, your answer will be 3.159, so it will be pi. Okay, so how do we find out a circle's circumference? So that measurement of the outside edge of that circle. We need 3 different values, okay? So we're trying to find the circumference in this case, so that would be C, in which case we need to know what the diameter is, and we need to know pi, okay? Now you might get a problem where you're not told the diameter, but you're told what the radius is. Now the relationship between the diameter and the diameter is from the origin out to the side of the circle, so the radius is half of the diameter. So if you're only given the radius, you need to multiply that by 2 to find out circumference, okay? Multiplied then by pi. So the calculation to find out the circumference is 2 times radius times pi, or the diameter times pi. Okay, so there's 2 different calculations to find you the same thing. Okay, now let's think about this a bit differently. If we cut our circle up into segments, okay, we can actually make a parallelogram like this. Okay, and we know with our parallelograms that at this end, if we cut this triangle off and we put it to that end, it becomes a rectangle. Now, our circumference is going to be the measurement along the bottom there and along the top there. So if we say that this measurement along the bottom is pi r, or it's half the circumference, okay, half the circumference is pi r, and we've got 2 pi r's, okay, so that's how our circumference becomes 2 pi r, or 2 r pi. Just remembering there's different ways we can write this. We can say 2 pi r or 2 r pi, or we can say d diameter times pi, because that radius is double the radius doubled is the diameter. Okay, so you might be given different pieces of information if you're problem solving with circles, okay? Or you might have different pieces of information. So it's really important that you know how to rearrange your formula, okay? So in this case, we are looking for our circumference, and we know that to find the circumference you multiply d or r squared, r times 2, okay? So c equals d multiplied, so diameter multiplied by pi, okay? Now, to rearrange that, if we was looking for diameter, we would then go circumference divided by pi. If we wanted to find out the pi, which is a constant so we know it, but if we did, we would go circumference divided by diameter. Okay, so moving now on to area. So we've looked at the circumference, that outside measurement of our circle. Now we want to know the area within the circle, so that space within the circle. Now remembering when we're looking at units of area, you may need to do conversions, and remembering that when you do your multiplication or your division, you are doing it by your 100, your 1000, your 10 squared. Okay, so thinking back to our circle opened up into our parallelogram as such. If we were trying to find the area of our parallelogram, we'd be doing length times width, because we would have turned it into that rectangle. Now, so we know that. We know we could turn our circle into that rectangle. We're remembering that Archimedes found that relationship between the diameter and the circumference. So we know we've got that value of pi. How does this all fit together? If we go back here, we know that one length of this rectangle shape is half the circumference, or it's pi r. So we've discussed that earlier. And the height as such, well, that's the length of the radius there, so that's r. So to find the radius of the circle, we've got pi there, and we've got r multiplied by r, which is r squared. So to find the area of a circle, we're doing pi r squared. So area of the circle, 2r is that height, and pi r is that width, so it's 2r's, which is the squared. R multiplied by r is r squared, so we've got pi r squared. Okay, so how do we rearrange different formulas? If we're looking for area, we know we've got pi r squared. Okay, if we are trying to find pi, we're going to be doing area divided by r squared. Now, here's the tricky one. If we want to find the radius, we don't just do area divided by pi, because we need to work out the squared here. Now, the reciprocal, or the opposite to squaring, is finding the square root. Okay, so the radius would be the square root of area divided by pi. So remembering your BODMAS, you do what's in the bracket first, or enter it into, if you've got a graphics calculator, you'd enter the full thing in. However, if not, you'd do area divided by pi, and then you'd find the square root of that. Okay, so we've found out how to find the area of a full circle, but how then do we find the area of individual sectors of the circle? And I've just put here some other pieces of information, some other keywords to do with our circles. So we have sector. Now, segments don't necessarily go from the origin out. Okay, segments are areas chopped off that don't go through the origin. If it goes through the origin, then it's a sector. And arcs are just sections of the circumference. They're just some extra keywords for you to know. Okay, so we're bringing degrees into this, guys, and it's not as scary as it sounds. Remembering there are 360 degrees in a circle. That's the first thing you need to remember. Now, if we're looking at the area of a semicircle, that is 180 degrees. Okay, so we've got 0 there, 180 there. So 180 divided by 360 is half. Okay, we know that a semicircle is half of a circle. So area equals half times pi r squared. So pi r squared is our area of our circle, and we want to know what half of the area is. So that's why we do it like that. If we was looking at how we could rearrange that equation, area equals pi r squared is how we find our area. We'd be looking for half of pi because we're looking at that semicircle. So we'd say area divided by r squared. If we're trying to find the radius, we'd be saying area divided by half of pi, but remembering that we've got our square root there. Okay, quadrants. Quad is a quarter. Okay, so we're looking at 90 degrees now. So 90 divided by 360. Okay, or we can simplify to 1/4. And then we just go area equals 1/4 multiplied by pi r squared, because we're looking at a quarter of our circle at 90 degrees. Okay, and then we've got the different ways that we could establish that. Okay, so looking at other sectors, so I've done the common ones, I've done half, I've done a quarter. What about if we were looking at 30 degrees, so this sector here? Okay, so we'd say 30 divided by 360. Can we simplify that? Yep, that's 1/12. Looking at your factors there. Okay, so we'd say 1/12 times pi r squared. Another sector. Okay, so we're looking at 135 degrees over out of our 360. Don't think that can be simplified, so we can put it straight in like that. So 135 over 360 times pi r squared. And that's all for our foundation revision on circles.